Now we go into detail the junction field effect transistor. Let's take a look the operation and the characteristic of JFET. Okay, and again you will see this figure, okay, as I showed in previous video. Okay, so the JFET operation, okay, I divide into two mechanisms so that you can understand it, how it works. Okay, the number one is applying voltage supply VDD, which is the positive VDS, and increase this VDS value to the positive value. Okay, it means that when I say the applying VDD here, we apply the positive VDD at the D and S terminal. Okay, at the D and S terminal. Okay, when we apply the VDD, it means that you will get the voltage VDS here. Okay, because you connect the terminal positive at the D, negative terminal at S. So it means that this is the positive VDD or VDS. Okay, so the second one is applying the gate to source voltage VGS from 0 to the negative value. This we will see in the next slide. Okay, I want to explain first for the applying the VDD for the positive value at the D and S. Okay, for this first operation, okay, when the VDD is applied, the free electron, okay, in N channel will move from S to D. Okay, from S to D. Okay, this process generate the drain current ID, okay, that flow from D to S. You see, okay, electron and S has the opposite direction. Electron flow from S to D, and current will flow from D to S. Okay, this is the ID. Okay, the more positive VDS or VDD, more ID current is generated. Okay, I will show you. First, okay, because of this positive, okay, positive voltage will attract the electron inside the N-type. Okay, in N-type there are a lot of electron, okay, the free electron. So this electron is actually attracted to the positive, okay, and it will move from S to D. Okay, because of this, it means that the current actually goes from D to S. Okay, sorry, from D to S. The current move from D to S. And then when I increase this value, let's say at first I put it 2 volt, then I increase, for example, to 5 volt. Okay, to 5 volt. It means that at the top part here, at the D, this is the 5 volt. Okay, it will attract more electron. Okay, so more electron will be here. Okay, will flow from S to D. So it means that the ID will increase. The value ID will increase. So you must remember that the use of VDD or VDS is used to generate the electron. The more positive this value, which is if we increase the VDD, so the more current will flow. Okay, the bigger current will flow. Next, we go to the second mechanism, which is we apply the VGS from 0 to negative voltage. See this, from 0 to negative voltage. Okay, I show you the connection of 0 volt for the VGS and negative VGS here. Okay, the gate to source voltage, the VGS, is act as a gate controller. And as I mentioned before, gate G and S is a controller because it will close. Okay, we will close this gate and prevent the electron to move from S to D. So the VGS control the N channel by closing the gate. Okay, by closing the gate. Okay, the first diagram shows when VGS equal to 0. So this is the origin condition for the gate. It still have a conduction part, okay, at the end channel. So then it means that the VGS control the flow of the drain current. Okay, and then we can imagine that how big the N channel at that time. Okay, at the origin, this is the big is this big. Alright. Okay, so more electron can flow. The more negative VGS here, the more negative VGS, the channel become more narrow. Okay, remember that when I turn the VGS into negative voltage here for the second diagram here, what happened? This part will be grow, the depletion region will be grow, and it happened the part here, conduction part, will be narrow, okay, until pinch off occurs, where the channel is actually totally closed. Pinch off is the condition where the depletion region touch each other, okay, until it blocks the current flow here. So you must remember that the application of VGS less than 0, it used to control the gate. Okay. In previous slide, I explained about the function of the VDD and also the function about the VGS. Okay. And what happened if these two processes are combined? Okay, actually, in the JFET operation, we must have these two supply. First, the VDD is used to generate the electron, and the second one, the VGS, is used to control the gate. Okay, let me see the first diagram here. Okay, the first diagram. First diagram, I put the VDD is 2 volt, okay, and the VGS is 0. So at this time, the electron is generated because this is 2 volt at the top here, positive, attract or it pull the electron. So we have current flow now from D to S. Okay, this is the current flow. Let's say the amount of current flow is 1 milliampere. Okay, then at the second diagram, see the second diagram, I maintain the VGS equal to 0. However, I increase this VDD into 4 volt. What happened at this time? The current is still flow, and it increase. At this time, here is the 4 volt at the top, at the D terminal. It will attract the electron more compared to the 2 volt. However, you have to remember the PN junction process where there is a reverse bias, because this is 0 volt and this is 4 volt. It means that this is the N type, so between the P and N, so here is reverse bias operation, so the depletion become larger and larger because of this 4 volt here. So what happened, even though the current is increased, the depletion region also will grow. Okay, now we get, you see this graph. For example, when I increase this 4 volt for the VDD, so what happened? The current is increased, okay, from 2 here and to here for the 4 volt, and then it keeps increasing. And for the diagram number 3, okay, you see, I keep increase the VDD to 6 volt. Okay, means that at the D terminal is 6 volt. So it keeps increase the current. However, the depletion region becomes bigger and bigger and bigger until it touch each other at the left side and at the right side. This is because the reverse bias in this area is very high. So what happened? Once a pinch off happen, it means that it close the channel. So the the electron cannot move from S to D anymore. So you see here, the 6 volt here, what happened at this time? This is the pinch off happen. So after that, it still has electron actually, okay, it still have some electron move, and the value of electron that move is maintained at this level. Okay, it's not keep increasing anymore because the channel is already closed and it just maintain its value. So we call this the saturation level. So remember that the saturation level is achieved when the pinch off happen here. Okay, pinch off at VDD is 6 volt, VDD or VDS, 6 volt. Okay, so we call this VDS is pinch off voltage or VP. I can say that now this VDS is 6 volt and it is equal to VP for this VGS equal to 0. So you will get this graph. Okay. Okay, I repeat again. During the VDD equals to 2V, there is an electron flows, and then we increase its value for 4 volt. The depletion region is growing, and then next, when increase again to 6 volt, it's grow and grow until pinch off happen is here. So the amount of electron is maintained, okay, from the last voltage here. So it increase and it maintain at the saturation level.